which emerged relative to seeding depth. So all of these were seeded at 325 seeds per square meter, which is a lot higher than a lot of you seed. I recognize this was later seeded. But basically, when you seeded at 1 inch seeding depth, we got 255 plants emerged. When we increased the seeding depth down to 2 inch, we had 214 plants that emerged. This should be 4 inches, not 3. We got 184 plants per square meter emerge. So there's two messages. It's important, number one, that we get consistent seeding depth, consistency, but we also need to be ready to increase seeding rates as your seeding depth is increased based upon the reduction of plants and tillers per plant caused or impacted by the increased seeding depth. Okay? This is some work out of Canada that kind of takes it a little bit further than the one I showed a minute ago. This is a good research document. I understand you'll have this presentation to go through at a later date, but this is a good paper to read if you're interested in reading research papers. But basically, this set of research, averaged over 2 years, replicated work again, shows that 72%, and this was good seed, good germination, good vigor seed. If you've got poorer germination, poorer vigor seed, after a wet harvest like this past year, you may see greater differences still. But in this particular set of trial data, 72% of plants emerged within a 3-day window. And I don't mean plant into emergence. I'm talking about between the first plant emerging and 72% of the plants emerging, they emerged within 3 days when seeded at 1 inch. As the seeding depth was increased to 2 inches, they found that 79% emerged within a 5-day window. If you increase the seeding depth down to 3 inches, they found that 81% emerged within a 7-day window. So what does that mean to you guys from a point of view of yields and profits? Well, in the conclusion, I cut and copied and pasted this out of the conclusion. Averaged across 2 years' worth of data, wheat plants that emerged on days 1 to day 3, meaning a consistent emergence, produced 1.4 times the yield of those which emerged on days 4 to 6, and 3.2 times the emergence, 3.2 times the yield of those which emerged on days 7 to 9. Okay? If you go and look on corn, if you start doing some research on corn, if you start doing research on soybeans, you'll see similar data sets. The early emerging plants get ahead of the later emerging plants and do better. Okay? So it all goes back to the concept of trying to get seeds in the ground evenly, good seeds in the ground evenly, getting them up out of the ground consistently. This was some row spacing work I did back in 2007. This is in Jewel, Kansas, north-central Kansas, 10, 12-inch rainfall area, so pretty dry rainfall area. Basically what we did, Great Plains helped us with this particular trial. They got us 2 identical drills. The only difference was the row spacing. Basically, we turned this field into a replicated trial. It wasn't randomly replicated. It was a strip trial in which we just seeded one pass next to the other, alternating entire field, 7.5 versus 10-inch row spacing. Okay? So basically what we're doing, the gentleman from Great Plains calibrated both seeders for the same number of seeds per square meter. Seeding depth was set to be the same. In this particular example, to get moisture, the seeding depth was set at 1.5 inches. So we got 2 almost identical seeders, the difference obviously being row spacing. And not that the row spacing had a huge impact on yield. We thought it would have a bigger impact. This is what the 7.5-inch rows look like at flag leaf emergence. This is what the 10-inch rows obviously look like at flag leaf emergence also. In this particular trial, a number of replications, the 10-inch rows was 3.75 tons a hectare. The 10-inch was 3.75. The 7.5-inch rows was 3.87. So not a huge difference, but there was a difference. My concern is when guys start going out to 12, 13, or 15-inch rows, and I'll give you some illustrations for that in just a minute or two. There's certainly some growers out there that are wanting to plant wheat with corn planters on 15-inch rows, okay? The benefit is obviously going to be improved seed distribution. You cannot match certainly not with the equipment I've been privileged to see and work with, you cannot match the standards of seed distribution in the row with an air seeder or an air distribution system to what you have with a planter. With a vacuum planter, positive cells, positive vacuum, positive distribution of seeds in the row is a plus, okay? So when we do research on 15 versus 7.5-inch rows, we try to work with planters to try and get the best possible seed distribution in the row and then compare it to a 7.5 drill with normal distribution through an air system, okay? This is an example of that. So this is 15-inch wheat on the left-hand side as you view it, planted with a corn planter. Very good seed distribution in a no-till environment. On the right-hand side, we've got 7.5-inch wheat planted with an air seeder with more random seed distribution. Pretty good stands on both sides, okay? When it came to harvest time, in this particular example, and again we're comparing 15-inch rows with a planter with good seed distribution to 7.5 with more variable seed distribution, and this is almost 10% difference, 5.74 compared to 5.26, okay? So 10% would be, $100 a hectare. And I've told a lot of growers on this trip and other trips, if there was a nutrient or a chemical or a micronutrient that consistently showed a 10% yield advantage in a lot of trials, you'd be all over it. But some of you, I think, are willing to give up 10% going out to 15-inch rows, okay? This is a more in-depth trial. This is with the OptiCrop group that I used to manage a few years ago. They do a lot of research still on wheat. So in this example, there's a lot going on, and I'll try and explain this. This is obviously a more in-depth, replicated random trial. In this particular example, we're looking across the bottom at 4 different seeding rates per square meter. We've got 125 seeds per square meter, 167, 209, and 250. So we're starting out with 4 different seeding rates, live seeds sown per square meter. Okay? We've then got 2 different row spacings. The first one is 15 inches with what we call the low nitrogen rate, 15 inches with the high nitrogen rate. We've then got 7.5-inch rows with the low nitrogen rate, 7.5-inch rows with the higher nitrogen rate. Okay? So then we're replicating this across 4 different seeding rates. So again, if you start to look at this data set, 5.6 tons a hectare, 5.9 with the higher nitrogen rate, so we've got 0.3 tons a hectare difference, benefit, I guess, with the higher nitrogen rates, but the yields were relatively stable with the narrow rows of 7.5s, but we saw about a 10% yield increase in this example to the 7.5s. Saw the same at 167 seeds per square meter, similar correlation at 209 seeds per square meter, and a similar correlation again. So we're seeing a trend in which the narrow rows, the 7.5s, are out yielding the 15s within this particular data set. So the local universities, despite Obama's spending cuts, a lot of the local universities in the US still do quite a lot of good research. And I was at a field day recently when they were looking at the impact, the economic impact of different seeding rates. And this was one of the researchers, 2 of the researchers, I guess, and they were comparing what we consider to be the standard, which is 7 or 8-inch rows, to wide, which is 10-inch, maybe even up to 15-inch, and they were also looking at 3.5-inch rows, the economic impact of 3.5-inch rows. And it was interesting to see, they showed a number of different slides. This is one where they were talking about 15-inch wheat. Obviously, it says the positives here, reducing machinery inventory, which obviously gives you the ability to plant more crops with the same seeder. Row unit planters do a better job with depth and seed distribution. The planters do. Perhaps reduce seed costs with planters. Some other benefits too, but the major ones. But let's look down here at the negatives.